Hello everybody and welcome to the next video of the course. In this video we will revisit conditional statements because conditional statements and us, we have some unfinished business. And that unfinished business involves concepts of and or within conditional statements, and also the fact that you can have conditional statements inside of conditional statements. You can have if statements within if statements, which is what it means to be nested. So we'll cover both of those concepts in this video. Okay, so let's begin with and or. And before we do that, I need to back up a little bit and give this definition just from logic. This isn't computer sciencey necessarily. You'll find this definition in logic textbooks. A Boolean expression is a statement that is either true or false. So here are some examples. 2 plus 2 equals 4. That is true. 3 minus 1 equals 7. That is false. X greater than 9 depends on what the value of x is, but once you have a value of x, you can evaluate that statement as either true or false. If x is 10, it's true. If x is 1, that's false. X plus y less than or equal to 30, again, depends on the values of x and y, but once you have values of x and y, you can assign a truth value to that statement. If x and y are both 2, that statement is false. If x is 10 and y is 40, that statement is false. Okay, so here are a couple of Englishy sentences. DTS 190 is your favorite course this semester. That's obviously true. Dr. McCune is the best human you know, if not the best human in the entire world. That's also obviously true, etc. Okay, so that's what a Boolean expression is. It's a statement that can be evaluated for its truth value, right? You can either call it true or false. Here are some non-Boolean expressions. Hi, what school do you go to? Just the statement X. None of those statements can be evaluated as either true or false. Like the statement hi, right? I mean, it makes no sense as some sort of logical statement, right? That would be either true or false. X here, notice, right? You're not comparing X to something, right? X bigger than 9, you could assign a truth value to that based on whether X were bigger than 9 or not. But just X on its own, there's no way to call that statement true or false. So why bother with this definition? Well, the answer is that in Python, when we set up these conditional statements, these if statements, when you write if something, and then the colon, right, that blank that goes in there, that's got to be a Boolean expression, right? Because the way Python works when it gets to this if statement, it decides if this statement is true or false, and if it's true, it does whatever code you've told it to do next. If it's false, the code just skips over it, But the code or Python evaluates whether it's true or false and then does something based off of that. But if you just wrote here, like if hi, what is Python supposed to do with that? It can't decide if that statement is true or false. So it doesn't know whether to do the code you gave it or to skip over it. Or if x, if that's all you write, if x, it can't evaluate if just x is true or false, so it doesn't know what to do. If you write if x is bigger than 9, it does know what to do. Okay, so that's the idea of a Boolean expression. So once you have a couple of Boolean expression going, you can form a new one using the logical conjunctive there, or. So you can form a new Boolean expression x or y as follows, just x or y, where now, if you want to know the truth value of that, x or y is true if either x or y, or maybe both, is true. Okay, but x or y has a definite truth or false value depending on the truth and false values of x and y. So just for example, if x is the expression x less than 6, y is the expression y equals 7, x or y is now just the two statements with an or in between them, and that statement is true if either x is less than 6 or y equals 7, or both, So if x is equal to 4, then x is less than 6. So there's a check mark right here. And then the other value can be whatever it wants. Y equals 8. Doesn't matter. The overall statement will be true because one of the pieces was true. If x equals 3 and y equals 7, now both of them are true. Both individual statements are true, so the overall statement is true. It can't be sort of doubly true. It's either true or false. But in any case, if either piece or both pieces are true, then the overall or statement is also true. So the only way to make this expression false is to break the first piece, make that false, and break the second piece, make that false. So here's an example like that. If x is 10, then the first piece is false, and if y is 9, the second piece is false. That makes the overall or statement false. Okay, and works similarly, except it's much more restrictive. X and y is true only if both x and y are true. So back with the or statement, right? X could be true, y could be true, they both could be true, right? So the or statement, it was pretty easy to be true. With x and y, both x and y have to be true. So if you think about x less than 6 and y equals 7 again, x and y is now this expression. In order for that to be true, both x must be less than 6 and y must equal 7. So if x is 4, well, you've satisfied the first piece because 4 is less than 6. But then if y is 8, you don't satisfy the second piece. So the overall and statement is false. On the other hand, if x is 2 and y is 7, now you get check marks in both spots, which means the overall expression is true. So that's the idea of and or. So in Python, if you want to write those English words, the translation is literal, and is and, or is or. That's nice. So here's an example of using an or. So you could ask the user what their name is and save it as response. If response is David uppercase or David lowercase, right, you could have the computer print hi David, right? You could ask the user, do you want this program to keep running? Enter yes or no. And if the user says yes, or little yes, or big Y, or lowercase y, right? Who knows what the user might enter? Any of those, if you want the computer or the program to keep running, then fine. Okay, so here we go and keep the program running. So that's how you can use an or statement. So just sometimes, if you want to check if something, that something might involve multiple conditions, right? So here I have 2 conditions to check, uppercase David or lowercase David. Here I have 4 conditions I could check. So or and in other situations allows you to just sort of check multiple things before you go into the code. You may or may not want to have the program execute. So the last thing I want to say about this is notice here I write if response equals David or response equals lowercase David. In English, we say if response equals David or lowercase David, right? In English, we omit this. Okay, as a matter of convenience, we do that in English. But in Python, you can't do that. You have to give it the full statement every time. If response equals uppercase David or response equals lowercase David. You have to do that or the code gets confused. Okay, so one of the ways that an and statement comes up is as a sort of validity of user input check. So to motivate how that works, I need to back up a little bit and show you what De Morgan's laws are. These are from logic. These aren't computer science concepts necessarily. So just to motivate why we might need these before I tell you what they are, consider this scenario. You want the user to enter either lowercase y or lowercase n in response to a question you ask them. So whatever. Do you want to play chess? Yes or no? And they're supposed to type either y or n. Well, suppose the user accidentally enters a t, because t is right next to y on the keyboard, whatever. Then you might want to have the user like just ask them again, right? Say, oh, I think you input something wrong. Please try again. So the code would have to go something like this. You get their response from them. And then what you want from them is either a y or an n. Well, suppose not that. Suppose they give you something that's not those things. So response is y or response is n not. Then what would you want? You would want to you'd want to tell them, right? Invalid input, try again. And for some reason, I've grabbed the response twice. I'm not sure why I did that. But whatever. You need to grab a response from them again, right? They entered something incorrectly. You now need to let them try again to grab a y or an n. So what De Morgan's laws allow us to do is actually deal with this. This is not Python right here. Python won't recognize this because it doesn't recognize the word not like this. But this is the idea of what you want. Okay, so again, the valid responses are y or n. So if the user gives you not that, something else, you have to tell Python, oh, let them try again. So the question is, right, this is an or statement. How do you not that? And then if there were an and here, right, how would you not that? De Morgan's laws tell you how to do that. So in Python, the word not is written as an exclamation mark. So not equals, for example, you write as exclamation mark equals. So again, the word not is not a word in Python. Like the way and was and, or was or, it doesn't work that way for not. Exclamation mark is a standard like logical symbol for not, so I guess Python writers just imported that from logic. Anyway, De Morgan's laws say this. If you want to not an or statement, the way you do it is by changing that or to an and nodding the individual components of that or. And if you want to not an and statement, not x and y, that becomes not x or not y. So basically the way that the logical not works is it flips ors to ands and vice versa, and it does not the individual statements. So if you had an x before, you'd have a not x now. If you had a y before, you have a not y now. So what does that mean? I had this or statement on the previous slide, response equals y or response equals n. If you want to not that, this or becomes an and. And you also have to not these individual statements. So response equals y becomes response not equal y. Response equals n becomes response not equal n. So that's how you can translate this English thing or English-y thing I had before into Python. If response equals y or response equals n is what you want, and the user does not that, then now you need to check if response wasn't equal to y and response wasn't equal to n. Then you got to get them to tell you something again. So here's how we translate that into Python. Again, do you want to play this game, yes or no? If response is not equal to y and response is not equal to n, then again, I'm not sure why I have both these lines here, right? But you just need to grab the input from them again, right? You need to make them try again. Invalid input, try again, you know? So now, hopefully this time they'll enter either a y or an n. Okay, so that's the material on and or. Basically, you can form bigger Boolean statements with more conditions to check if you would like. Just depends on the context and what you want the program to do. So now let's move on to nested conditionals. So to motivate this for you, imagine this scenario. You've written a program that lets the user play chess or checkers. And suppose that when the program opens, you want the user to make that choice. You know, do you want to play chess? Do you want to play checkers? However, after the user makes that choice, you have a follow-up question for them, which is, do you want to play hard or easy? And by the way, this is purely a thought experiment, right? Because at this point, we, of course, don't know how to write code to play chess or checkers, right? That's far beyond what we've done. But just imagine you have this code in your back pocket, right? You've spent the weekend or whatever writing code that lets the computer play chess with a user, and furthermore, you've developed hard mode code and easy mode code. Okay, so the question is, how would you let the user decide which game to play and in which mode? So how do you ask them this follow-up question once they've chosen a game? And the answer is you can use nested conditionals like this. This is just a schematic here, but you know, first you ask them 1 for chess, 2 for checkers. And if they enter 1, if response is 1, well, now you know they want to play chess, but at this point you don't know which mode. So then you can ask them now a follow-up question inside of this if. So notice all this is indented, right? So indentation means you're inside this if. So if response is 1, I'm going to now do all this. And what is all this? Well, now I ask them, do you want easy mode or hard mode? So if they enter 1, then now here's where my chess code easy code goes that I have supposedly written, right? But if they don't enter 1, they enter something else, then I guess I'll do hard mode. Okay, so again, the point of this example is here's an if-else structure right here. that if-else structure is living inside of a bigger if structure, which is right here, right? So all of that to say, you can put ifs inside of ifs, inside of ifs, inside of ifs if you want to, right? You can nest them as much as you want. It just depends on what the context is. So again, if response is 1, I'm going to do all this. I will ask them a follow-up question where that follow-up question also branches, based on the response. If they initially typed 2, which meant checkers, then again, I'll grab a response from them, 1 for easy, 2 for hard, and same sort of branching structure here, except I put my checkers code here that I have supposedly made, and my checkers code here in hard mode. Okay, so all that to say, you can put if statements inside of if statements if you would like. So that is the point of this video, being able to understand that you can do this nesting right here, and being able to understand those words and or inside of Boolean expressions, which appear in conditionals.